Hello, this is Frank with Accelerated Designs. I'm going to be demonstrating the Ultra Librarian tool for you here. We're going to be demonstrating the gold version. The purpose of the Ultra Librarian is to allow you to build parts in one location and export them to many different EDA CAD formats. We've got quite a few improvements over the previous versions, so I'd like to demonstrate these to you, featuring some of the changes one at a time. I'll also be reviewing some of our basic capabilities that have been in our tool for some length of time. To start with, I usually like to build a footprint because that's what everybody is mostly interested in when they look at tools of this sort. So we're going to create a footprint, and you notice we've got some lead types here. We'll narrow down into a specific part. I like to use this part. We divide our templates into two types basically. We have a calculated and a non-calculated. A non-calculated is simply a pad size that is given to you on a data sheet, and you give me the dimensions and the gaps around them. The calculated version, however, has a yellow area that represents the calculated size of the contact of the pin onto your printed circuit board. It also has keep out areas and so forth. All of this calculated based on the IPC standard. And we prefer to use that wherever we can, and some of the reasons why will show up as we go through our video. I'm going to select this part to build. It's moved it off screen, so I'll move it down here where you can see it. You can zoom in and out with the plus and minus keys. You have the ability to enter data on the left side, and as you enter it, if you hit apply, you'll see the results on the right side. I'm going to zoom in for a moment. In particular, what you're seeing in white here is the keep out area or the place boundary around the part. The yellow area is the calculated contact based on the information provided on the left side of the screen. Green, very faint, is the assembly drawing. The white lines here outside the assembly drawing represent the silk screen. Of course, you have a pin 1 marker here and here. One on the assembly and one on the silk screen. There is hidden data and hidden attributes. Everything's centered on the point of origin. So that's kind of what you're looking at. You'll notice that we've tried to mention as much of the major items as we can for you. Not all of this exports out into the tool. You saw me slide the video around. It's a right mouse button. So we may not want to represent some of these dimensions in your host tool just because of the room it takes up. But you can see the toe and the heel and the side dimensions as calculated here. As you change what's on the left side of the screen and hit apply, you'll see the changes in your part. You notice that I work in English units, but I can type metric units in by hitting MM, and it will properly calculate to 1 millimeter. It's accurate to 8 decimal places, far beyond any of the CAD tools we generally use, and I'm displaying just 2 units here because I don't like all the confusion. Now, if you wanted to, you could swap this around so you were entering metric units and just had a reference of what that is in English units. That's done in the setup. This is all based on IPC. We use the nominal size as our default size. That can be changed simply by moving to least. You notice that the contact area did not change in the least, only the pad sizes. You see much less pad there, and if we change that to maximum and hit apply, you see that we get a much larger pad size, and the keep outs or keep aways also change accordingly. I'll set that back. We also have the ability to put user-defined toe and heels in sides. We could put vias under the part. We can put keep outs under the part. We can put heat tabs under the part. All kinds of different ways that we could build this part that are reasonably standard in the world around us. I'm going to say done there. Now we have many templates that are designed to do different kinds of parts, and therefore have different questions on the left hand side. You'll notice too that up here we have a checkbox for 3D models, footprints, and symbols. I'll drag these windows down where you can see them. There's a footprint, there's a symbol, and hidden in behind here is your 3D model. And you'll notice that it's a 10-pin model based on the numbers we gave. Now what's important about this 3D model is it is dynamically created based on the information that you entered in your footprint. That means that this part will automatically be the correct size, the correct rotation, the correct point of origin, and so forth, as seen on your footprint. I think that's a very important piece. It's a labor saver for a lot of people. I'm going to go ahead and close some of those windows down just so that I don't crowd out our video too much. Now in addition to that, I've built this part. I can tag the part, and actually, let's tag the right part. That's a pad stack. And auto create a component that matches the footprint name. And off screen here, obviously I was not able to put pin names or function names into that symbol, but I have a matching cross-probable pin, as well as what's off the screen here that you can't see is a cross-probing screen. I have all of those available to me at this point. I can finish this off by entering some information in a spreadsheet or in that cross-probing screen, but there's other ways to do this. I'd like to demonstrate that. The point is that I can help you make a dynamically available part very quickly. Before I go do that though, what I'd like to do is build another footprint that's very simple. We're going to use a chip part. We're going to look for a resistor, and I'm going to here we go. Use the calculated version. Noticing the name that is automatically calculated at the top, I'll say done. If I take that footprint, right mouse button on it, it will automatically create for me a horizontal and vertical resistor and a resistor that contains all of that information. So you see I have a resistor horizontal here and a vertical symbol here. All of the mapping for that is all done. Another capability that I like to show people, let's delete this for right now, is our ability to make symbols. And we can do this several different ways, but I'm going to introduce a way that we like to use here in the office. And we use what we call a CSV, which is basically a ASCII representation of a spreadsheet. And it looks like this. It basically contains the name of the component, the name of a footprint, and then the pin information required to build that component. So what I'm going to do is I'm going to create a symbol here using our little button here at the top. I'm going to use it building with a wizard. Nope, I don't want to use a wizard. Let's don't do a wizard. Instead, we're going to do component creation screen. Again, I'm going to have to move this screen where you can see it. And I'm going to give it a name. I'm going to call it Frank because I have no imagination. Accept. I'm going to import that CSV file. And I would like to go to that one right there. And you notice it put that data right in here on the screen for me. I'll accept the data. I'll auto assign by pin number. Accept that data again. I'm going to select the footprint or the component name. Accept that. I'm going to add a footprint that has to already exist in the library. In this case, it picked out the correct one automatically from the CSV. I'll accept that. I'll verify the component. It says there's no errors. And then I'll be done. And now, when you look at this cross probe, you'll see that I can indeed cross probe between pins. And the data that was in that ASCII file is automatically loaded into our component, giving us a complete component in almost no time. But I can hear you. You're saying, Frank, there's a whole bunch of connections that should be grouped differently. These are all grouped in order by pin number, as you'll notice. How could I change that? Let me give you an example. I have a pre-existing part here. And in this part, we have one gate or one symbol that makes up that component. I'm going to double click that, and it will open up a screen similar to this here. Now you'll notice that this part is by default numbered 1 to 20 and in order by pin like you would see it on a component. I'm going to reverse that order on the right side, and I'm going to ask that it puts all of these pins on the left side grouped, and it automatically did it in order, alphabetically, numbers first. Now I might want to do that a little differently. Let's say I wanted to separate each pair. I could select them as pairs, add them in, now here I'm going to want to do something slightly different. I'm going to want to put the rest of these pairs on the other side, like this. And finally, I may want to take all of these and manually move them so that they're as far down that chip as they can be, right across from each other. So what you've seen demonstrated is a quick way that we divide up symbols and the pins on the symbol to make intelligent symbols. We think it's a really nifty way to work. It's the fastest I've been able to use in my work as a librarian, so I'd like to show it, like you to be able to see it. If we hit apply here, we can save this, and now when we cross probe, you see that symbol the way you just saw it on the screen. Now what's important to note about what I've told you so far is that all of this is the basis for a very large library. We currently have the largest library I'm aware of in the world of EDA components that are complete. That is at least a footprint, a symbol, and a component that ties them together. Now different tools will export them different ways. Our tool exports to a whole selection of capable tools. We have most of the popular tools in our list right now. And so if we wanted to export this, we could simply select the tool that we wanted to export to, or potentially tools that we would like to export to. And from that list, we'll then create an export for it. I was kind of looking for, there it is. I was looking for CADStar, those two. If I say OK at this point, it saves that, and I can export my libraries. And it will export 4 different components, 5 different symbols, 4 footprints, and 4 different 3D models. And it was that quick. Now you'll notice that we also give you a set of detailed instructions here on how to export each of these tools. As you go further down the instructions, there's also an HTML page that will give you pictures in order and so forth. and there's a YouTube page that you can go to get a video of us importing into Allegro, in this case, the data that we just created. So what I've shown you, I hope, is that we can build footprints quickly. We can dynamically create 3D models from those footprints. Now that's true of most of our parts in our library. About 85% of them have 3D models attached. The 15% that are left are parts that were built with generic templates that do not have really innately the ability to build a 3D model because they're so generic. We auto-created a symbol. We could manually move the data in that symbol around. We could import using ASCII files. There's actually about 8 or 10 different formats we can use to bring CSV files in. I've showed you how we can export to many different tools. I've talked about a 7.2 million component library. I haven't mentioned that all of this is based on ASCII files, which means the templates that you filled out to build footprints and symbols can all be modified to meet your standard in ASCII. It also means that our databases are primarily stored in ASCII. Amongst the capabilities that we have here is the ability to take what's in the library and generate binary files that can then be read by our free reader. Our free reader will only read pre-generated binary files. So we have 7.2 million of those files available to you in our tool, which means you could come over here, find an existing component, search for a component, when you find the particular component you're looking for, obviously you can find a part number. You can also look for the most recent library, which is what I would normally do. You can attach DigiKey metadata to it, add it to your library. You'll see that we tell you what we're working on, and when we're done, you come back and you have said part in your library. Again, it has attributes from DigiKey. It has the ability to cross probe, and look at what you have. And this will export to all the different tool sets we use. One last thing I'd like to point out that I think is a very big turn of events for us as a company, and could be for our customers and printed circuit board designers in general. We have a relationship now with DigiKey, and as you can see on DigiKey's page, when you search for a part, if we have it available, it will have a download from Accelerated Designs, your EDA and CAD models. You push a button, it will take you to our website. It will have the part that you've selected listed. It will show how many that you have remaining that you can get. We allow 5 per month this way, without buying a subscription or some additional parts. You could actually search online here for additional parts, and you can give me a list of parts and I'll go see how many of them I have. Once you've added all your parts into your list that you'd like, you can select your output format, and you'll see that here you can come over and select an output that you'd like. You can scroll down. You'll have to, third step, enable a license. It says you've read and agreed to our license, and then export those CAD files. The more export formats and the more files that you're exporting, the longer this process takes, but eventually you'll get to a download button. When you hit the download, it will download the parts for you. If you open it up, you'll see inside the formats that I had selected. And they'll contain the data that you were looking at. In the case of Altium, it's a script file that you'll run, and we have instructions on how to do that there. The one I didn't show you was the step files themselves. Here. So the goal here is that you can quickly, as a wrap-up, select from 7.2 million parts, many of them built on contract for the manufacturers that supply those parts. You can download them from DigiKey. You can get them from the manufacturers. If you don't see what you need in our database of parts or your manufacturer's parts, you also have an option of just building the parts yourself using our tools. We can modify what you download with the paid version of the tool so that symbols look more like what you'd like to see and so forth. And you can do all of this en masse with the paid versions. The free versions, one part at a time. I hope this gives you some idea of where we're headed as a company, what our tools are capable of today, and I look forward to critiques or comments on the video so I know how to make a better product for my fellow designers. Appreciate you taking the time.